In this video, we're going to introduce probability, a concept that's going to be very important as we continue our discussion on statistics. So we're going to kind of lay the framework here and go over some ground rules for probability that, again, we'll see quite a bit in the future. So in this video, we're going to look at determining the probability of an event. An event is simply nothing more than an outcome that we can measure the results. So, for instance, whether or not the Cleveland Browns win the Super Bowl, or maybe flipping a coin, or rolling two dice in a board game. Those would be examples of events because we can measure the outcome. So before we get into that, we're going to have to talk about what is known as sample space. And the sample space is a listing of all possible outcomes. Some sample spaces are quite small, for instance, flipping a coin. Others are quite large. For instance, the sums on rolling maybe 10 dice or so in a game. So some common sample spaces that we're going to talk about in this video include flipping a coin, which your outcomes are heads or tails. So we're not going to look at the very rare, freakishly rare occurrence of flipping the coin and having it land on its side. So here's your two outcomes for flipping a coin, heads or tails. Your sample space for rolling a single die are 1, 2, 3, 4, 5, and 6. So whatever, either the number itself, the numeral itself is on the face, or the pips. Some people call them dots, but they're pips would be on a lot of standard single die. Drawing a card from a standard deck. A standard deck of cards is 52 cards, ranging from with 4 suits each and 13 cards per suit. So we have cards such as the Ace of Spades, Ace of Hearts, all the way up to King of Diamonds. So we'll go over some of these cards in this video as well if you're not as familiar with them as other people. So in order to help us with probability and all that, we have visualization techniques. And a very nice visualization technique, which you may have seen in the past, it's called a Venn diagram. And Venn diagram is a visualization of events and sample spaces. So for instance, here we have a sample space, this rectangle. And let's say this sample space represents rolling a single die. So we know all the possible outcomes in this giant rectangle would be the numbers 1, 2, 3, 4, 5, and 6. Well, here we have an event, event A. And let's say event A is rolling an even number on a single die. So out of the 6 numbers, the 6 possible results that would be in this giant rectangle for sample space, the numbers 2, 4, and 6 would be inside this circle representing the event that you roll an even number. So we'd have 2, 4, and 6 inside this circle, and then 1, 3, and 5 outside this circle. So we'll be using Venn diagrams to help illustrate a lot of the concepts in this unit on probability, but just wanted to give you an introduction if you haven't seen Venn diagrams before. They're very helpful also with learning logic and logical reasoning. So, as mentioned before, we're going to be talking about playing cards. This is a standard deck. There are 4 suits. We have clubs, diamonds, hearts, and spades. The diamonds and hearts are the red cards. The spades and clubs are the black cards. And then we have 13 cards in each suit. We have an ace, and then we have the values 2 through 10, and then we have jack, queen, and king, giving us 13 cards per suit times 4 suits. There's 52 cards in a standard deck of cards. We don't include the joker or the playing instructions or anything like that. Over here, we have the jacks, the queens, and the kings. These cards, the jacks, the queens, and kings, the one with pictures on them, are referred to as face cards since they have faces of, I guess, people on them. So notice we have 3 of each type of face card, giving us 12 face cards. So if you're working with cards and it asks you about face cards, just note that there are 12 of them, but everything else is 2 through 10 and then an ace. So if you're not familiar with them, hopefully it's not too bad for getting a quick understanding of playing cards. All right, so probability itself is the measurement of the likelihood of an event occurring. So with probability, we want to know essentially it's a ratio of the number of ways that the event can occur divided by the total number of outcomes in the sample space. So, for instance, if we had drawing a card, there are 52 cards in the sample space. So we'd start with 52 in our denominator. And then if we wanted to, let's say, drawing an ace, there are 4 aces in the sample space. So 4 out of 52, which we could then reduce to 1 out of 13. So probability is just a measurement of the likelihood of an event occurring. So for the rest of this video, we're going to take a look at some examples of determining some probabilities of each event. Example 1A, what is the probability of flipping a coin and landing on heads? So if we take a look at what are the outcomes, we want to land on heads, and there's only one out of the 2 possible outcomes in the sample space. So we have heads or tails. So out of those 2 possible outcomes, we want one of them to happen. So a probability of flipping heads is 1/2 or 1/2, which is also the same probability as flipping tails. Another way to think of probability is the number of ways that you want the event to happen out of the total number of ways possible for the sample space. So it's what you want to happen over what could happen as another way to determine probability. Part B, rolling a number less than 3 on a single die. Well, we know that on the values 1 through 6 for a single die, 6 possibilities in our sample space, 2 of those possibilities are less than 3. If we rolled a 1 or we rolled a 2, for whatever reason we want to roll less than 3. So there's 2 ways that could happen, either a 1 or a 2, out of the 6 possible outcomes. So our probability is going to be 2 out of 6, which reduces to 1/3. So we always reduce our probabilities when possible. We could also express this as a decimal. 1/3 is 0.3 repeating, or as a percentage, which is 33.3% with a bar over the last 3 there in the decimal place. So we can express it as a decimal, a fraction, or a percentage. And we'll see variations of those throughout this unit. Part C, drawing a face card from a standard deck. Well, we know that there are 12 face cards, which include jacks, queens, and kings, and then 4 suits each with clubs, diamonds, hearts, and spades. So jack, queen, and king, each one of these suits is represented. So we have, again, 12 face cards from the jack of clubs all the way to the king of spades. So we have 12 face cards out of the 52 total cards. 12 out of 52 reduces to 3/13. And if we go back to our illustration of going back way, where are you? There we go. Went a little too fast. Each one of these suits, we have 3 out of those 13 cards is going to be a face card. So again, another way we can look at it. But yeah, it's 12 out of 52, which reduces to 3/13. All right, part D, the number of students in each class at a college is shown in the table below. So we have 1,670 freshmen, 2,017 sophomores, 2,975 juniors, and 3,026 seniors. Find the probability that a randomly selected student is a sophomore. So we need to know how many total students there are in this college. It's one thing we're not told. So if we add up all these class sizes here, we get 9,688 students attending the college. Well, out of those 9,688 students, 2,017 of them are sophomores. So our probability is 2,017 out of 9,688, which is not going to be able to be reduced. This is actually as lowest terms as we can get. So it's roughly about a little bit more than 20% of the students at the school are sophomores. All right, part E, we have the 36 possible sums from rolling 2 dice. So if we're playing a game that requires 2 dice, like a lot of board games do, we have 36 possible sums that we can get. But notice a lot of these sums are repeated. So for instance, we have a total of 3 different ways to roll a 4. We could roll a 3 and a 1. We could roll a 2 and a 2, or we could roll a 1 and a 3 to get a 4. So what is the probability of rolling a sum of 7? So we want to know, let's say we're really interested for, maybe we're going to win the game if we roll a 7. Well, we need to know how many possible ways are there of rolling a 7. And if we count along this diagonal, we see there are a total of 6 possible ways out of the 36 total. So our probability of rolling a sum of 7 is 6 out of 36, which reduces to 1/6. So you have actually the best chance of rolling a 7 than any other possible outcome when rolling 2 dice. So maybe use that to your advantage, or maybe not. It's up to you. But in any event, that about does it for this video. Thanks for watching. I'll see you next time.